Good morning, everyone. My name is Ibrahim Arabi, and today I will be talking about periodic trends in the periodic table. So, what are periodic trends? Periodic trends are specific patterns in the properties of chemical elements that are revealed in the periodic table. Major periodic trends include electron activity, ionization energy, electron affinity, atomic radii, ionic radius, metallic character, and chemical reactivity. Of these, I will be talking about 5. So let's discuss a few key terms that will be used in this presentation. The first key term would be effective nuclear charge, which is the attractive positive charge of nuclear protons acting on valence electrons. The second key term is electron shielding, and it's the blocking of valence shell electron attraction by the nucleus. The third key term would be Coulomb's law, which is an experimental law of physics that quantifies the amount of force between two stationary electrically charged particles. Now, there are two formulas to remember. The first one, which would be Coulomb's law, and the second is effective nuclear charge. So the first periodic trend we will be talking about is ionization energy. As we can see in the background, ionization energy increases from left to right and bottom to top. Now we will see why. So what is ionization energy? The energy required to remove an electron from a neutral atom in its gaseous phase. Now let's talk about this in terms of effective nuclear charge. The greater the atomic number, which means the greater number of protons in the nucleus, the greater the ionization energy. Now, because there are more protons in the nucleus, there will be a greater attraction between the nucleus and valence electrons, therefore we'll need more energy to remove valence electrons. Now, in terms of electron shielding, the more electrons shielding the outer electron shell from the nucleus, the lesser energy is required to expel an electron from the atom. Now, this only applies in terms of from the top of the periodic table to the bottom because electron shielding increases from top to bottom. Now, in terms of Coulomb's law, the greater the nuclear charge and the shorter the distance between the nucleus and the outermost electron, the stronger the attraction between the nucleus and the electron. As a result, the electron will require more energy to remove. Now, if the atom is smaller and has a greater nuclear charge, then it will require more energy to remove a valence electron. So the second and third periodic trends we'll be talking about today are atomic and ionic radii. As we can see in the background, the atomic radii decreases as we go from left to right, and we can see at the top right it's the smallest compared to the bottom left it's the biggest. Now, atomic and ionic radius is the distance from the atom's nucleus to the outer edge of the electron cloud. In terms of effective nuclear charge, across a period, effective nuclear charge increases as electron shielding remains the same. A higher effective nuclear charge causes greater attractions to electrons, pulling the electron cloud closer to the nucleus, which results in a smaller atomic radius. Now, as we said before, the more protons there are in the nucleus, the greater the attraction is between the valence electrons and the nucleus, therefore the atom will be smaller and more compressed. Now, in terms of electron shielding, down a group, the atomic radius increases as the nuclear shielding increases. Across a period, the atomic radius decreases as the nuclear shielding stays the same. Now, the atomic radius increases as the nuclear shielding increases because the core electrons are repelling the valence electrons, therefore it becomes bigger. Now, in terms of Coulomb's law, atomic radius increases from top to bottom within a group because there is bigger distance between the protons in the nucleus and the outer electron. So the next periodic trend we'll be talking about is electron affinity. So electron affinity is the amount of energy released when an electron is attached to a neutral atom or molecule in the gaseous state to form a negative ion. Now, in terms of effective nuclear charge, electron affinity increases upward for the group and from left to right across a period of a periodic table because the electrons added to energy levels become closer to the nucleus. Now, in terms of electron shielding, as one goes down the period, the shielding effect increases. Thus, repulsion occurs between the electrons. The stronger the attraction, the more energy is released. Now, in terms of Coulomb's law, the smaller the atom is, the closer the outermost shell is. Therefore, is a stronger attraction between the nucleus and the incoming electron. That means the electron affinity is higher for smaller atoms. Therefore, when we look into the periodic table back here, we can see that at the top right corner, electron affinity is at its highest. So the next periodic table and the last periodic table trend we will be talking about is electronegativity. As we can see in the background, electronegativity increases from left to right and from bottom to top. What is electronegativity? Electronegativity is the tendency for an atom of a given element to attract shared electrons when forming a chemical bond. A good example is H2O, where oxygen attracts the electrons for hydrogen. That's why oxygen usually has a negative charge and hydrogen has a positive charge, and therefore H2O is a polar compound. Now, in terms of effective nuclear charge is directly proportional to electronegativity. The more nuclear charge, the higher the electronegativity is. Now, for electron shielding, the more shielding there is, the lower the electronegativity, so they're inversely proportional. And according to Coulomb's law, as atomic number increases with a series of atoms, the nuclear attraction for electrons will also increase, thus the pulling of the electrons closer to the nucleus. So the more the nuclear attraction there is in a atom, the higher the electronegativity there will be. So thank you for listening, and here are my sources.